this juncture, allow me to officially take you through the Arduino board. You will note that the board we are currently using is specifically the Arduino Uno, as you can read from that, and it has different parts and components that as you can see. So we're going to start with this specific part. We're going to start with this part. We're going to start with that part. So that part is called a power jack, and to be specific, you can just call it a barrel jack. Number one, you can call it a barrel jack. So with a barrel jack, that's just a place where you can plug in power from a battery. You know, you can power the Arduino board either from the computer or directly from a 9-volt or any other kind of battery. So I will take you to part number 2, and part number 2 is going to be this part here. That is our part number 2. Our part number 2 is the USB port, and what the USB port does, the USB port is responsible for programming the board itself, or having the board powered directly by the computer. So you can kill two birds with the same stone. As you're programming the board, you can also power the board directly to through the computer. So that's our part number 2. So after part number 2, we are headed to our part number 3, and the part number 3 is an internal part, and that part I will just have to point it because you might not be able to see it very well. So the part number 3 is this part. You will note that there is a part here having TX, and there's also a part here having RX. So the RX is an LED. It's an LED which will be lighting when you have connections doing different things. For example, the RX, this RX, what the RX means, the LED is an internal LED. The RX just shows when the Arduino is receiving data, such as when being programmed. It will blink. Then our number 5, not number 5, number 4 is going to be the TX. This is the TX. So with the TX, we just call it transmitting. This will always blink while you are transmitting data. So while you are transmitting data, this TX will be blinking. But while you are receiving the data, the RX will be the one blinking. Those are internal LEDs. Now we also have another internal LED. We will be using it very often. So the internal LED is our number 5, and you will see something like L there written, L. So this L, which is just next to our GND, next to our ground, next to pin 13, this is our internal LED. So if we don't want to connect to do the connections like we had previously, we just want to test if our Arduino board is running or if the program is working, we will always run a program which will blink this LED, which is called L, and it's connected to pin number 13. It's an internal light emitting diode. Diodes have, LEDs have different shapes, so this is an internal one. So that's about that. We will go straight away to number 6, which are now the pins. And these pins we are talking about, the number 6 pins we are talking about, are these pins which run from here. These pins which run from here to here. So these pins, you'll note that we have 0 to 13. We normally call these pins digital pins. We call them digital pins, and you'll come to understand why we call them digital pins. So those pins are called digital pins. So with digital pins, most of them are just, all of them are just VCC pins. And what we mean by VCC, with these pins, they give out 5 volts. And these are the pins that we use to program. Take this one as our brain. When this brain sends a signal, for example, we want to light something, the voltage will come out from either of these pins, depending on which pin we are using. And that voltage, after going through the component we have connected to from these pins, 5 volts, always they give out 5 volts. It will now, after that component, it will now go to the GND as we talked of earlier. We can either use this GND here, this ground, or use these grounds that we are having here. So these ones at the top, they're the ones who say they're digital pins. So after digital pins, we are heading directly to our other part. You will note that there is this thing here. This one is the reset. This one is the reset. It is the reset button. And what the reset button does, the reset button just makes it possible for you to reload the program. That is, in case you are running something and your board may be hanged for some reasons or something, so you will just hit the reset button and your program will start afresh, just like restarting. So your reset button is let's call it button number 8. So your button number 8 is the reset button. Always press that if you want your program to start afresh, to start from the beginning. Always press this button. So that's all about the reset button. We also have other pins. You will note just next to me here at the bottom here, you can see some pins named from A0 to A5. So these pins that have been named from A0 to A5, we normally call these pins analog pins. We normally call them analog pins. We normally call them analog pins. So you might be wondering, what's the function of the analog pins? So the function of the analog pins is like sensors. So you have your circuit connected to sensors. For example, you want to use a light sensor such that if that light sensor is receiving a certain signal, you want the program to do something, or you've connected a potentiometer to one of those analog pins. So those pins normally read that specific pin, and they can tell you the actual voltage or the actual current that is passing is normally converted to voltage, that current converted to voltage. So it will tell you the the actual current that is flowing from that potentiometer to here, and you can easily program this brain of it. We call it the microprocessor. This microprocessor, you can program it to either, for example, if it gets that you have turned that potentiometer maybe to 6 volts, maybe it can light something else. Maybe if it gets to 3 volts, it can maybe stop a motor or something. So everything you run from here. Take this thing, this one at the center, as the brain of this board. It's like your brain. And this one, the analog A0 to A5, they are the receptors. That's where you connect your sensors. And your sensor, if we're comparing that to a body, a sensor would be something like the skin. If you have something burn your skin, information will run to your brain that there is something that has burned your skin. So the information from this Arduino board, it will run using wires. So from here, the wires will take the information to the brain, which is this chip. Then the brain, depending on how you've programmed it, what will happen if I feel there is fire on my skin, I have to withdraw my hand. So it will send that signal back to something which will help your hand to be withdrawn, and those are like the joints. And for this purpose, this one can be something like a motor or something. So for the wires will now come from here, now these digital pins, and now head maybe to a motor or something. So if this you've detected maybe a certain temperature, I want you to turn the motor on. So maybe line number 13 was not having power. So if you program this one, if I get a minus something in A0, you will turn number 13 on. So number 13 that will be here, it will start moving. So that's just a nutshell of the Arduino, and that's how the Arduino works. It's just like the brain of electronics. Just like you have a brain, it has a microchip. Just that like you have the skin which sense, they have sensors which are connected to the A0s. And just the way you have legs to move, you can connect your motors and everything in these analog pins, in these digital pins, not analog, from 0 to 13. So hope you now have all the information about the Arduino, and this is what we will be programming and we will be using in our next steps.